everybody, and thank you for having me. My name's John. I work for a company called ConsenSys, and we are primarily concerned with something called Ethereum. And I guess we'll talk a little bit about that today and get into some of the blockchain components. Try to understand the context within Web3, exactly what Web3 is and how that relates to IoT. Okay, so I guess I'll give a really quick overview on exactly what the blockchain is, and I'm sorry for my breakfast colleagues, you're going to hear the same story again. So there's a lot of noise and a lot of discussion, and I don't like doing slides, so I'm just going to have this, and I'm going to show you some tech later. So just a bit of historical context to understand the blockchain, because there's a lot of noise and a lot of discussion about it these days, but generally very little solid understanding. So we go back in time a little bit to post-World War II, and initially American corporations first started using computers and experimenting with computers in their business processes. And very quickly into the 1960s, there was a new problem that never existed before. There was all this data that had to be structured and organized and made queryable. And then in the late 60s, early 70s, a guy named Codd invented the Relational Database. So this is where we get the database. And then going into the 70s, there was all these databases that started popping up all over the United States, Western Europe, Japan, different parts of Asia. And there was demand to connect them all, so this kind of gives rise to the notion of the network. And so now we've got the database, and we've got the network, and basically on top, we start building applications that start to look like the internet. And that's roughly the architecture of the stuff that underpins our digital economies and societies today. And it's worked pretty well. However, we're entering in sort of new phase where the complexity of our digital economy is growing very quickly, and somehow this configuration, this old configuration, is suboptimal. One very obvious glaring example is financial services, and we talked about this morning at breakfast. Like most of our money today is a number on a digital screen, and so the way the internet was architected has enabled institutions to build siloed fiefdoms and kingdoms that they control and protect, and that has led to some inefficiencies. So if we think about something like PayPal, PayPal controls sort of a database or a set of databases that has some pretty useful functionality for regular people that expresses itself as a financial service. And so if you want to start an online business and accept payments, you need something like PayPal or a merchant services account with a Visa or MasterCard, etc. And recently, PayPal blocked all of Turkey. It's like a big country. I'm not blaming them per se, I'm just saying they have the ability to do that. And like banks have the ability to selectively kind of choose who they offer services to, etc. Because fundamentally, the architecture of the internet allows them to restrict access. And so in 2009, shortly after the near collapse of the financial system, like the zombie apocalypse almost, this Bitcoin thing emerged. And it came out of nowhere. It just sort of emerged from the internet, and it gave us this blockchain notion. And so what the blockchain fundamentally does is it takes the database and the network and kind of marries the two, so they become coterminous. And in the case of Bitcoin, the way it does that very simply is you have this very large distributed network of many computers around the world, all plugged in, forming a network. That is the network, scattered computing nodes all over the world. And inside of every computing node, you have the same database, so you have a massively replicated database. And so you've taken the network and the database and you've kind of put them together. And at predictable time intervals, in the case of Bitcoin, roughly every 10 minutes, all of these computers sort of achieve consensus on the state of the network, and they kind of like publish a statement of truth about the network that we call a block. And So that block gets sort of filled with the next round of transactions, and everybody agrees. And so over time, you get many blocks, and they're all chained. So we get this blockchain kind of term. And there are some interesting properties with this configuration. It is very difficult to go back in time and alter a previous block. So anything that happened in the past, like let's say any transactions or any activity that is recorded and massively replicated across this database, is very hard to go back in time and alter that. The reason is because you would need to basically take control of a majority of the network. Like there isn't one central point that you could manipulate. You would have to substantially manipulate a majority, or in some instances all of the nodes in the network. And of course, the bigger the network gets, the harder it is to do that. Therefore, we can think of the blockchain in some ways as a source of truth. And so within this context, this Bitcoin context, we also have a very large shared view of reality. So we've got all these different scattered computing nodes that are kind of like seeing and agreeing on the same thing. And within this view of reality, we can do some interesting things. Like we can engage in peer-to-peer interactions and transactions, and we can transfer value without needing like sort of middlemen or custodians to process that transaction for us. And so that's Bitcoin. And of course, it's grown over time. It's become a global phenomenon. And excuse me. And as that's happened, people around the world have started to look at this blockchain thing and started to ask questions about how it can be applied to more complex business logic beyond just trading these tokens of value between ourselves peer-to-peer. And as it turns out, if you are interested in more complex business logic, so whether that's things, I don't know, like contract for differences, whether that's things like complex insurance products, whether that's things like peer-to-peer energy trading, whatever it may be, is very, very, very difficult to make use of Bitcoin for anything more complex than just basically trading around Bitcoins. The reason for that is because Bitcoin is elegant in its simplicity. It is designed for like one purpose, and it does this one thing very securely, and that's about it. If you're a programmer and if you want to build anything interesting into the security of the Bitcoin network, it's like programming in the 70s. Like, it's really hard. There's a small space that you need to stuff a bunch of data that you care about, and there's not that many people in the world that are like expert, deep, cryptography, math, computer science experts that can usefully mutate the code. And so we've never really seen Bitcoin deliver the promise of the blockchain beyond just, like I said, exchanges and wallets and things that trade tokens around. But as this global open source project has developed, people have learned, they've sort of collaborated, and towards the end of 2014, so roughly 5 years after Bitcoin came out, this thing called Ethereum emerged. And so that logo, that triangle logo, is the logo for Ethereum. And the reason I put this image up is to demonstrate that the blockchain, and you hear that term thrown around, as just the tip of the iceberg. It's really the Web 3.0 infrastructure underneath it, of which Ethereum is a critical component that is most interesting. And so Ethereum, like Bitcoin, is a very large distributed network of scattered computing nodes all over the world. You have a sort of replicated database across all the computing nodes. And you also have, and this is the differentiator from Bitcoin, you also have a shared replicated virtual machine. And so what that means is, if Bitcoin is like a world calculator, Ethereum is like a world computer. If Bitcoin is like your old BlackBerry phone that's really good at trading secure text messages, but that's pretty much it. I know the new BlackBerries can do more, but the old ones, that's pretty much all they did. Ethereum starts to look like your iPhone or your Android, where it's a platform onto which developers can build next generation applications that we call decentralized applications. And so now as a user, you have a different user experience, because there's all kinds of cool stuff you can build and deploy onto this shared global IT infrastructure, this world computer. It also has some optimization, some properties that differentiate it from Bitcoin in that it's faster. So Bitcoin block times are 10 minutes, Ethereum block times are like 15 seconds, and they will get much faster in the coming years. So it represents, it kind of takes, Ethereum took what Bitcoin gave us, and it just made it better and more general. And so that has some pretty interesting ramifications in the IoT context, which we'll talk a little bit about in the next 10 minutes or so. So Ethereum has become a global phenomenon. It is being widely adopted. It's kind of in the middle of this hockey stick exponential growth curve. There are large corporations and governments all over the world adopting it. There's something called the Enterprise Ethereum Alliance, and so that's some of the biggest corporations in the world working together. The Dubai government, for example, is building a bunch of cool stuff on Ethereum, and so are other governments. I was in Hong Kong recently, and they obviously have a smart city initiative as well, and it looks like Ethereum will be underpinning a lot of that infrastructure as they move forward. And so here in Singapore, as this becomes an even more connected city, it's quite interesting to ask ourselves, well, what does the sort of protocol, like what does the communications protocol layer look like underneath all of these smart devices that start to come online and talk to each other? And so I'm going to talk a bit about identity, because identity is really the most critical, or it's one of the more critical components to like elegantly scaling out the IoT future that we all sort of think about. And I'm going to show you a quick demo. So like, let's think about identity in the context of people, and let's think about it in the context of Facebook. So Facebook is like a container for identity. You sign up, you agree to their terms of service, which means you have zero rights, which means that you will never get any money, you will be totally exploited, and that's just the way it is. And so now you have a profile, and you upload attributes that describe who you are. So your name, your birthday, where you work, where you live, your relationship, etc. And others, your friends, make attestations. So they attest against those attributes. When somebody tags you in a photo, they are attesting that they know that's you, or they know that face to be you. When they say happy birthday, they're attesting that that date is your birthday. Happy anniversary, they're saying, I know you're with this person and you've been together for... So over time, you have this constellation of attestations against your attributes, and this forms the notion of identity. And sometimes Facebook will give you transitive identity, like you can log into Airbnb. There are many apps that are built on Facebook. I think Tinder is the most successful one with like 100 or 200 million users. And same thing for like LinkedIn for your professional identity. But your identity belongs to them. It is not persistent and transitive. Like you can't go everywhere with it, right? That's why there's username and passwords everywhere we go and everywhere we use the internet, because you have to create an identity and put that information into somebody else's database, which you don't actually control or you don't own. You just have access to. Unless, of course, they take your rights away, which happens very often. And so if we start to reimagine what our digital identity constructs could look like where users have control, Ethereum becomes really interesting. And so, again, Ethereum is this massively sort of distributed, shared IT infrastructure. It is a world computer that no corporation owns, and yet everybody owns. Excuse me. I got a really bad head cold. I got sick 2 days ago. Just bad timing because I can't taste anything, and there's so much delicious food in Singapore. And so you've got this shared global IT infrastructure that nobody owns, yet everybody owns. And into this IT infrastructure, we can start to rebuild or reimagine some of these services. Like, for example, I can inject a transaction into Ethereum that will give me a unique public identifier, a public key, and I can attach to that all of these identity attributes that would otherwise be resident in Facebook or LinkedIn or what have you. And I can introduce the notion of attestations, like we were talking this morning. I can go to the post office in Germany, I can show them my documents, they can verify those documents, and then the post office can cryptographically sign with their identity against my identity. So now I have an attestation. And maybe I take that attestation and I go to, I don't know, UBS or Deutsche Bank, and I open a bank account with it. And maybe I'm a good customer and I pay my bills, and I get another attestation from Deutsche Bank. And now I have 2 attestations. And so over time, I can collect these attestations against my blockchain resident identity. And because I have the private key, okay, which is a unique corresponding alphanumeric string of characters to my public key, which is resident and massively replicated on the World Computer Database, because I have the private key, I have custody over my identity. And that's kind of the big deal. And I can selectively disclose identity information to different parties depending on the context that I'm in. And so that's in the case of people. It's the same thing in the case of machines. So if you imagine like the electrical grid, and as the grid decentralizes more and more, as more solar and batteries and distributed energy resources come online, the fundamental business model of the grid changes, where consumers become prosumers and things decentralize. So what happens when my neighbor is producing power from his or her photovoltaic system, and I would like to consume some of their power? Maybe my dishwasher or my refrigerator or some other appliance. These machines can have blockchain resident identities from which they can ascertain and establish and authenticate each other. And then they can do things like transact complex business logic and the financial settlement and payment across this one shared substrate. So that's fundamentally very different than the way people have been imagining the IoT space in the past. And so if we start to really think about billions of different devices, hundreds, thousands, or tens of thousands of different manufacturers, all these devices with different protocols, like one shared source of truth, one shared substrate to manage identity, to manage the business logic, and to manage the financial transaction is where these systems become quite interesting. So I'm going to show you an example of logging into a website without usernames and passwords. So this is something called Gnosis, which is a decentralized application that my company built. It's a prediction market. We don't have to get into the weeds of the application because it's less important, but basically it is a decentralized next-generation Web3 application. And a prediction market is really cool because you can, as a user, create a market like, I don't know, will Trump win the election, yes or no? And people can buy shares of yes or no. And depending on the price of yes or no, you have a pretty good idea of what people really think. So it's a way of crowdsourcing wisdom. And so this thing has a QR code. It doesn't have a username. It doesn't have a password. What I'm going to use, here, let me just show you Uport really quickly. So what I'm going to use is something called Uport, which is, it's a mobile self-sovereign identity management app. Let me see if there's anything interesting here. No, there's nothing interesting here. So I've got this app on my phone. I'll try to show it to you guys. It's basically like if you've ever downloaded a Bitcoin wallet or even something like Snapchat. It's a very familiar user experience where, let me show you. So I can kind of, maybe you can't see, but I can make claims about myself, like my name, where I work, my email, et cetera, et cetera. And then I've got this scan QR code function. So let me see if I can scan this guy. One second. Okay, so I've scanned with my app, and now it's asking me if I wish to share my identity attributes with that application. So rather than me logging in to their database, which contains my identity information, I am simply selectively disclosing, and now it's logging me in, and so I can start to interact with whatever the contents of the website are. So basically the idea here is that selective disclosure and user control is kind of the foundational pillar for what we think Web 3.0 technologies, web technologies will look like. So no longer does your identity belong to others and you have to sort of ask for somebody to verify you. By virtue of controlling your own private key, you can go ahead and have full sort of custody and sovereignty over your identity. And so that becomes very powerful if any of you have, for example, Bitcoin or any other cryptocurrencies where you have custody over your money. So when you put your money in a bank account, you don't actually have custody over it. You have an IOU, like the bank agrees to redeem your request and give you money upon request, assuming like they don't go bankrupt or there isn't a run on the banks or something bad happens. And you have trust in that. But unless your money is like, I don't know, in gold and that's under your bed mattress, you don't actually have custody over it. It's resident with that institution. So with cryptocurrencies, because you have the private key in your custody, you have custody over those funds. And with these next generation identity systems, because you have the private key that corresponds to the global database where your identity attributes are resident, you have custody over your identity. So those are two very big paradigm shifts. And then you start to apply that to things like browsing and logging into next generation web applications by selectively disclosing things about your identity that satisfy requirements to let you in. So let's think about that. For example, you want to get a mortgage and you want 5 competing rates from 5 different banks. Well, today you would have to go to like 5 different websites, open a bank account. It'd be a very painful experience. I mean, you would have to go through KYC, AML. You'd have to go through all these steps every single time. With self-sovereign identity systems, you could simply basically scan and selectively disclose, and now you're in. And so, you know, I want to impress upon everybody here that when we think about the blockchain, when we think about some of these things, it's very important to understand this identity construct because it's really a game changer. And so I think the example we were talking about this morning as well was, like in the IoT context, was the smart refrigerator. And again, I'll use the grid, the electrical grid example. I don't think the smart refrigerator that can like order groceries when it's low on food is all that interesting. But I do think the smart refrigerator that can shift its electrical consumption depending on grid conditions is much more interesting. And so again, if my neighbor or a series of neighbors are producing power, and maybe they're overproducing because it's really sunny, and there's a surplus, well, maybe that's a great opportunity for these IoT devices to talk to each other, signal, and then transact things like the business logic of, I want to buy X amount of kilowatt hours from you at this time, at this price, and then actually go ahead and execute the transaction. And before all of that, ascertain each other's identity. So you can start to imagine, whether it's in smart meters or appliances, basically embedded chips that have a private key resident on these devices. And so, you know, all of these devices start to come online with their own self-sovereign identity. Okay, so that was a bit of a mouthful. I wanted to try to get through as much of this as possible. I got a few more seconds. The other thing I was gonna say is, so one of the really important things to consider is this notion of interoperability. So one of the things that limits, for example, a smart city or a collection of smart cities from realizing some of the things that we often talk about in the IoT context is the fact that there are many different sort of agencies, institutions, whether they're government or in the private sector, what have you, that play different roles in our societies and economies. Getting different databases to talk to each other is actually pretty hard, and it can be expensive. When we start to reimagine things on a shared IT infrastructure, that interoperability becomes quite interesting and quite valuable. And so now you can really start to imagine the art of the possible of whether it's IoT devices interacting with other IoT devices or other services within a smart city. Okay, I think I'm over time. So thank you very much. If there's any questions, I'll be around. Feel free to ask. Thank you. Is there a question and answer or no? Yeah. No? Yeah. Sorry?
I have a question on the safety of QR code. No technology is immune to hacking. So as such, QR code with a MIM, you can actually log in and get a QR code, and you can clone it, and you can then actually hack it by brute force or by cloning. And this has been proven actually last month by an Egyptian scientist. So I want your comment on this hack-proof thing.
Sure. So
it has been proven it can be cloned, and it has been done. Thank you.
Yeah, so I think for the purpose of the demo, we use the QR code. But so public key, so the QR code is a visual representation of a alphanumeric string of characters, a public key. So you could you could develop systems that don't necessarily rely on a QR code. I mean, if you wanted to be like really secure, it would just be, copy paste exactly this public key rather than scan the graphical representation of it. There's a bunch of different ways to do it, but essentially, it's the public key and the private key are very unique. How we decide to represent them is, I guess, depending on the context. Like if you had something super mission critical that wasn't necessarily a consumer product, maybe you wouldn't use a QR code. But I think for most, certainly these kinds of applications, it's probably okay. Anything else? All right, thank you very much.